In this video, I'm going to talk to you about arithmetic sequences and series. Let's begin by looking at these different patterns. If we examine what is happening from one stage to the next, in the first pattern to the left, we're going to see that from pattern 1 to pattern 2, we added one new box. From pattern 2 to pattern 3, we added one more box. And from pattern 3 to pattern 4, we added one more box. So it is easy to see that here the pattern is plus 1. Plus 1 box, plus 1 box, plus 1 box. We're adding a constant amount from pattern to pattern. Now, if we look at the second pattern here in the top right, we're going to see that the difference between the different stages that we're showing is that we're also adding one box to get to the next stage, always plus 1. This quantity is fixed and is not changing throughout the stages. And if we look at the bottom right image, we have 3 stages. We can see that from diagram 1 to diagram 2, we added 2 squares. We added this one and this one. So that makes it 2 new squares. From diagram 2 to diagram 3, we added 2 more squares. These type of sequences where we are adding a constant amount from one stage to the next is called an arithmetic sequence. In terms of numbers, we can represent these sequences like this. This sequence would be 1, 2, 3, 4. The second sequence would also be 1, 2, 3, 4, and 5. The third one is 3, 5, 7. There are 2 elements that are going to characterize our arithmetic sequences. The first one is going to be the first term of the sequence, and the second one is going to be the common difference. In sequences 1 and 2, we can see that the numbers in our sequence are the same. That means their characteristic values are going to be also the same. The first term of the first sequence is 1. Let's call it A1 is 1. But since these two represent the same sequence, I can also use the same symbol to represent the first term of the second sequence. A1 is 1. And the common difference for both is equal to 1 as well. Now, if we look at the third sequence, 3, 5, and 7, the values are different. We have the first term of the sequence, let's call it B1, is going to be 3, and the common difference, D, is going to be 2. Once we have these 2 elements, the first term of the sequence and the common difference, we are able to develop what would be the general term for the sequence. In order to get the general term of this sequence, let's just focus on the third sequence. Let's consider the first few terms of the sequence. I'm going to write them down as B1 is 3, B2 is 5, B3 is 7. We know B4 is going to be plus 2 to the 7, so 9. And we're interested in knowing what Bn is going to be, where n is going to represent the nth term of the sequence, and Bn is going to be an expression that depends on n, and we can calculate this term or any term using the formula that Bn is going to provide. So I want to write 3, making explicitly the amount of times I am adding the common difference. So I know that 3 is simply 3, but 5 is 3 plus 2. 7 is 3 plus 2, and I added one more 2. 9 is 3 plus 2 plus 2 and plus 2. So I can notice that the number that is being represented by the number of the term, for example, B2 is represented by n equals 2, is one more than the number of 2's I am adding in the term. For example, look at B3, I'm adding 2 2's. In B4, I am adding 3 2's. Always one less than the counter of the term. So that means if the counter of the term is n, I will have n minus 1 2's adding at the end. So my general formula is going to be 3 plus 2 times the number of the term minus 1, n minus 1. Now I can make this even more general by recognizing that Bn is going to be 3, which is the first term, B1, plus 2, which is the common difference, D, times n minus 1. So now I got a formula that is general and will work for any arithmetic sequence. Let's take a look at an example to see how we would apply this formula. In an arithmetic sequence, U3 is 12 and U10 is 40. The common difference is D. A, write down two equations in U1 and D to show this information. So we want to express both U3 and U10 using the general formula. Remember from the previous discussion that the general formula is UN is U1 plus n minus 1 times the common difference. So for U3, we can write U1 plus 3 minus 1 times the common difference. And if we substitute the values that we have, so U1 plus 2D equals 12, we get the first equation. Now the second equation is going to come from U10. U10 is going to be U1 plus 10 minus 1 times D, and this is going to be equal to 40. So the second equation is U1 plus 9D equals to 40. Now for part B, we are asked to find the values of U1 and D. What we built in the first part was a system of two equations with two unknowns that we can solve simultaneously. So we're going to subtract both equations, but we're going to do it in the order U1 plus 9D equal 40, take away the second equation. So when we subtract them, U1 minus U1 is 0, 9D minus 2D is 7D, and 40 minus 12 is 28. So D is equal to 28 divided by 7 means D is equal to 4. Now that we have D, we can take either the first equation or the second equation that we found in A to substitute to find U1. So let's take U1 plus 2D, so 2 times 4, is equal to 12. That means that U1 is going to be 12 minus 8. So U1 takes the value of 4 as well. Finally, in C, they're asking us find the 100th term of the sequence. The 100th term of the sequence will be given, again, following this formula. But we're going to substitute n with 100. So U1, which is 4, plus 100 minus 1 times D, which is also 4. This is equal to 4 plus 99 times 4. That is the same as 100 times 4. So that is 4 hundredths. Now in the second example, if you want, you can pause for a moment, read it, and then try to do it by yourselves. If you have tried to do it by yourselves, now we should check. Pablo made monthly payments to his bank for a loan. The payments for the first 5 months were 55, 52, 49, 46, and 43. A, write down an expression for the nth term of this sequence. So looking at the sequence, you can see that the first term of the sequence is 55 and that the common difference is negative because the numbers are getting smaller each time. And also, if you subtract 52 minus 55, you're going to get that the common difference is negative 3 right here. So A, U1 is 55 and then D is minus 3. If we want an expression for the nth term of the sequence, we need to go to the recursive definition. Un equals U1 plus n minus 1 times D. And we substitute the values of U1 and D, and that would be 55 plus n minus 1 times minus 3. Now we could finish here and say this is the solution to this question. But if you want to simplify it, you can also do that. You would just need to expand. 55 plus minus 3 times n gives you negative 3n. And minus 3 times minus 1 is plus 3. So you can say that the recursive definition or the general term is going to be 58 minus 3n. And this can be the simplified version of the recursive definition. Now in part B, they ask about the amount of Pablo's 12th payment. So how much is he going to pay on the 12th month? So that's going to be U12. And we're just going to calculate it with 55 plus 12 minus 1 times minus 3. And that is equal to 22. Now in question C, they ask, determine when Pablo will make his last payment. So the last payment is going to be when he's going to pay 0, right? So we need to know when he is going to achieve a payment of 0. We need to equate UN to 0. So we're going to do, I'm going to use the simplified version for this, but you could do the long version as well. You could do 58 minus 3n is equal to 0, means 58 is equal to 3n. So n is going to be 58 divided by 3, and this is 19.3. So 19.333. But we know that n has to be an integer. It has to be either 19 or 20th. So in this case, if we go to 20, the value of the term is going to be negative. So you can't make negative payments. So if we do 19, that should be our final payment. So our answer is going to be 19. It has to be an integer value. Finally, for D, they want to know how much is he paying last. That means what is the value of the 19th payment. So that's going to be 55. Actually, let's use the simplified formula for the space of 58 minus 3 times 19, and that is equal to 1. Finally, we need to talk about the arithmetic series. The arithmetic series is the sum of the terms of an arithmetic sequence. We're going to define the partial series as n, as the partial sum, meaning it is the sum of the first n terms of the sequence. So you're going to be adding all of the terms from a1 all the way to an, and if you stop there, that's the partial sum, Sn. In a sequence like 1 plus 3 plus 5 plus 9, the sequence 1, 3, 5, 9 corresponds to an arithmetic sequence, but adding the terms together corresponds to the arithmetic series. Now, you can have partial sums. For example, if we consider the sequence an 1, 3, 5, 7, 9, then you can do S1 would be the sum of the first term of the sequence, A1, which would be equal to 1. S2, the second partial sum, would be A1 plus A2, and that is, in the case of this sequence, 1 plus 3. For the third partial sum, that is A1 plus A2 plus A3, and that is 1 plus 3 plus 5. The value of the series would be doing the sum. So 4 for the second sum and 9 for the third sum. And you can continue doing this all the way to your desired length of the sum. So if you want to add n terms, you're going to be doing this process n times. However, you are not expected to carry out sums that are too lengthy. Instead, you can use the formula that I'm going to give you for the arithmetic series. Sn can be found by taking n divided by 2 times 2 times the first term of the sequence plus n minus 1 times the common difference. An alternative expression would be taking n divided by 2 and multiplying by a1 plus an. There are advantages to each of these formulas. For example, in the first case, if you know the common difference and the first term, you can use this formula. But if you don't know the common difference, you are not able to use this formula. If instead you know the first term and the last term that you intend for the sum, you can use this version instead. Let's finish with an example. An arithmetic series has S1 equals 4 and common difference equals minus 3. Write down the expression for Sn in terms of n. So, we are given S1 equals to 4. What this means is that A1 is equal to 4 because S1 is the sum of the first term of the sequence. So S1 and A1 will always coincide. So I know A1 is 4. Now they want me to write an expression for Sn. I already have a formula for that. N over 2 times A1 plus n minus 1 times the common difference. So I'm just going to substitute A1 with 4 plus n minus 1 times the common difference, which is minus 3. So this is going to be n over 2, 8 minus 3n plus 3. Now 8 plus 3 is 11. So n over 2, 11 minus 3, n. That would be the formula for Sn. We shouldn't work it out further for the time being. So we're going to keep it like that and work on B next. B says find S10. S10 is the substitution of n with 10 into the formula. So 10 over 2, 11 minus 3 times 10. And this is 5, 11 minus 30. And this is equal to minus 95. Now for C, they say find the smallest value of n for which the sum is going to be less than 250. So we need to solve the equation n over 2 times 11 minus 3n is less than minus 250. So what I would do in this case is try to solve this equation with the calculator. One way that is easy that you can do is graphing. So if you graph on the vertical axis Sn and on the horizontal axis you draw n, you're going to be able to see the intersection between minus 250 and Sn. So I'm going to draw a window from maybe the minimum, because we need to see the 250. I should secure a minimum of maybe minus 300 and a maximum of maybe 10 so that we can see the 4, right? Once you graph this, Sn should look something like this. It should do a little bit of up and then down. And then minus 250 is a straight line that is horizontal somewhere here in the bottom. The intersection is this point right here. How are we going to do it? We're going to do it with the calculator. We're going to find the intersection, and the calculator is going to tell us that this intersection is happening when n takes the value of 14.87. We need to figure out which value of n is the real answer, because n can only take integer values. So the answer has to be either 14 or 15. Remember, we need to be under minus 250, right? That means in our graph, we need to be in this area once we have crossed already minus 250. So the first value is going to be 15. If we look at 14, we haven't crossed it yet. But with 15, we will have crossed it already. So the answer is n equals 15.